at section 2.2 on what we call simplifying expressions. So this section is about making expressions as simple as possible so that it is easier to solve with them later. So we want things as cleaned up and simple as possible when we start to learn how to solve. So it says, which do you prefer? If you just glanced at either this expression or this expression and you had to choose which one you wanted to work with, I think we would all choose the second expression because it looks easier. In fact, these are the same. One has not been simplified and one has been simplified. So that just shows you if we can simplify, our life will be much easier when we get to solving. So just to show that, we're going to evaluate each of the above expressions when c equals 20. So I'm going to take this first expression, which is 2c minus 10 minus c plus 15, and plug in 20 everywhere I see the letter c. So 2 times 20 minus 10 minus 20 plus 15. 2 times 20 is 40 minus 10 minus 20 plus 15. 40 minus 10 is 30. You can see how much work this is. Minus 20, let's see, 30 minus 20 is 10, and then plus 15 gets me to 25. That was layers, right? 4 or 5 steps of work. If I plug in 20 into the second expression, it's just 20 plus 5, and we are done. So you can clearly see that it's a lot less work if we can simplify before we start solving. So it's all about the number of terms. A term is a variable or constant separated, sorry, I'm squishing my work together. A variable or constant separated by adding or subtracting. A variable or constant separated by adding or subtracting. So again, if we look at these top two expressions, the first expression has 1, 2, 3, 4 terms. 4 pieces of information that are separated by adding or subtracting. So I think of these kind of like train cars. Here's the first train car, and then it's connection with the second, connected with the third, connected with the fourth. So there's 4 terms in the first expression. In the second expression, there's a c and there's a plus 5. So the second expression only has 2 terms. That's why it's so much easier to work with. So the number of terms can help us decide if it's simplified or not. If you've got 4 or 5 terms still, you've not simplified. If you get it down to 2 terms, you've got it simplified. Alright, so let's look at some examples here. I put a lot on the page. If it gets too overwhelming, just take a piece of paper, cover them up, just one at a time. If you need more space, you can work on a separate sheet of paper, just that you don't want to cram your notes together. So if I didn't give you enough space, just get a sheet of paper and add on to the notes as you need to. So what we're going to do is combine like terms to simplify. CLT is what you'll see me write when we're practicing this. So combine like terms. A like term means that variables can combine together and constants can combine together. So anything that has the same variable can go together, anything that has the same constant can go together, and it's by adding and subtracting. So I think it's easier if we just jump in and start simplifying. So if we have 2c minus 10 minus c plus 15, I think I'm going to work on a separate sheet of paper here. 2c minus 10 minus c plus 15. If you have different color pens at home, this might help. The C terms, so 2C and minus C are like terms because they both have the letter C. They're also going to have coefficients. This has a coefficient of 2 and this has a coefficient of 1. Then the minus 10 and the plus 15 are like terms. And this student showed me once that if you use boxes around like terms and circles around other like terms, it can help you separate things. So let's just focus on the variables. We have 2C minus 1C. And you're going to add or subtract the constants. So 2C minus 1C gives us 1C. When the coefficient is positive 1, we usually just write the letter. And now, let's combine the numbers. We have negative 10 and positive 15. Negative 10 plus 15 is positive 5. It might help to keep the symbol on there, plus 5. So this expression, which is the one we had to begin with, simplifies to C plus 5, which is the other expression we were looking at. So you put your C's together, you put your numbers together by adding and subtracting using the rules we learned in operations. On the second one, we have 4A minus 6A. The symbol in front of the term goes with it. So 4A minus 6A. At first, you might need to write that down on your scratch paper, 4A minus 6A. Anytime you're subtracting, if you're more comfortable doing keep, change, that's fine. You should end up with negative 2A. Don't lose your letters, so the letters stay on that term, negative 2A. And then we can put our B terms together. We have plus B and plus B. There's a 1, so it's like plus 1B plus 1B. 1 plus 1 is positive 2B. We generally like to keep the terms alphabetical, so the A's go before the B's, but you cannot lose those variables. So negative 2A plus 2B. And again, if you have different colors, it makes it much more clear of how to combine things. Alright, we have a few more to try. Again, if you'd like to pause and try them on your own, you're more than welcome to. If you'd like to follow along, that's fine too. So here we have negative 6x and positive 6x. Negative 6 plus 6 works out to 0. When you have 0x, you don't have to write anything. So I say it disappears. So the x terms cancel out's not the best word, but they can make 0. And so all we have left to deal with is positive 5 and positive 2, which makes positive 7. So you can write 0x plus 7, but really what they want is just plain old 7. So that's all you have left. The next one, we have a negative 3x, and notice none of the other terms have x. So we're just going to leave that one alone, negative 3x. And then we have lots of constants to combine. We have negative 5 plus 12 plus 10. So left to right, negative 5 plus 12 is positive 7 plus 10 is positive 17. So you can combine all your constants together and you go from 4 terms down to 2 terms. We can usually get it down to 2 terms or sometimes even just 1 term when we're simplifying. Alright, and then finally we have 3b squared minus 7b squared. So the b squareds go together. That's going to make negative 4b squared. Now we're not actually squaring that number. Students like to take this way too far. Don't do anything, it's just b squared. That's just the term. To get the exponent on your homework, you have to use the blue boxes on the side. If you have a hard time with that, just email me. and then plus 4d squared, because it's all by itself. So again, we're not actually squaring anything, it's just a different type of term. When you see those exponents, we don't have to do anything with them. It's just a different type of term. And b goes before d in the alphabet. So combining like terms is the most common way that we simplify. We gather everything that is the same together so that we have less to look at. Another way we simplify is with multiplication. So we can simplify these using multiplication. We have 4 times 3x, which is 12x. 5 times negative 10y is negative 50y. Notice the letter stays with it, don't forget that. Negative 6 times 3b is negative 18b. And negative 4 times negative 2x squared. Again, just focus on the coefficients. Negative 4 times negative 2 is positive 8. X squared is just the term. That little square doesn't do anything. It's just there. So multiplication comes in with what we call the distributive property. So the distributive property is very useful. You've probably seen this one before. I put a few on here. And then the last couple kind of combine all the steps. So again, if I didn't give you enough space for these, just work on a separate page. If you're doing okay, we'll keep going. If you need to pause and go back, you're always welcome to do that. So the distributive property looks like this. We take the number in front of the parentheses, and since it's right up against the parentheses, that indicates multiplication. We multiply it times the first term and times the second term. So we have 3x plus 3 times 5 is 15. So when you have a coefficient or a number and a variable being multiplied, you don't do anything, it just becomes 3x. And then again, this is 7a plus 70. Positive and negative rules still apply. This will be negative 15b minus 10. Here we have negative 16 plus 4c. So negative 4 times positive 4 is negative 16, and then negative 4 times negative c is positive 4c. There's a 1 here. If you need to write that 1, that's okay. There's a 1, so it's really negative 1c. On this one, we have this little 8 plus hanging out here. Students are extremely tempted to add the 8 and the 3. But remember, the order of operations says we have to do multiplication before we do addition. So PEMDAS still applies here. Before we add or subtract, we have to multiply or divide. And the distributive property is multiplication. So the 8 and the plus are just going to hang out there for a minute. We're going to distribute this 3 and get 3x and then minus 6. So we have 8 plus 3x minus 6. And now we can combine like terms to make it even simpler. So CLT, we can put our 8 with our minus 6. We like to have the variable first and then the constant. And so you're going to put your positive 3x first, and then 8 minus 6 is positive 2. So that's called combining like terms. And then you get it down. It had a lot going on, then it had 3 terms, and now we've got it down to 2 terms. We want it as simple as possible. Same idea with the one next to it. 2 times 3w and 2 times 4, so that's 6w plus 8. And then the minus 5 is just going to hang out there for a minute. It only distributes to what's in the parentheses. I think it's very, very important to draw those little arches. Another teacher told me to help you remember the distributive property. If you think hippity-hoppity distributive property, I know it's silly, it rhymes, but you have to hippity and you have to hoppity. You have to multiply each term inside those parentheses. So that's called the hippity-hoppity distributive property. And I still, to this day, draw those lines so that I don't forget. If I don't draw those lines, I'm bound to forget. A lot of students forget about the second value. So from here we can CLT, 6W will stay there. Positive 8 can combine with negative 5, so 8 minus 5 is positive 3. If you'd like to pause the video and try these last two, they're a little more complicated. Remembering distributive property comes first, and then combine like terms, because the distributive property is multiplication, combining like terms is adding and subtracting. So if you'd like to pause and try those bottom two, and I'll go through them in just a second. I'm going to work these on a separate sheet so I don't run out of room. First thing you're going to do here is distribute. Leave everything else the same. So negative y plus, this is going to become 6y plus 15 minus 18. I'll go ahead and write that here. So you have negative y plus 6y plus 15 minus 18. So you're distributing. Now you have four terms you need to combine. This is negative 1y plus 6y. So if we put these together, you should get positive 5y. We have positive 15 and negative 18, or a better way to think about that, positive 15 minus 18 is negative 3. You can do keep, change if it helps. So you should have gotten 5y minus 3 for your final answer. Alright, and then the last one here. We're going to multiply this out. It'll make negative 12y. I'm going to leave the minus 5 alone. It's very tempting to do the 5 and the 2 together, but the 2 is being multiplied, so we have to distribute first. So it's going to be plus 10y plus 14. So again, we multiplied here to get negative 12y. The minus 5 we left alone. It's very tempting to add those together, but the 2 is being distributed to get positive 10y plus 14. So remember, we're still following the order of operations. And from there we can combine like terms. So we have negative 12y and positive 10y makes negative 2y. And then negative 5 and positive 14, let's see, that makes positive 9. And you put your variable before your constant. Variable goes first, then your constant. Variable, and then constant. Technically, it's correct if you get them switched around, but the computer wants the variable first, and then the constant. So simplifying expressions is very important. You want to get really good at simplifying expressions. No matter how crazy they get, you need to be able to simplify them. Because in order to solve, which we're going to do next, in order to solve, your simplifying skills need to be very, very good. So if you want to stop here and practice the first 20 questions of your homework and do the extra practice on simplifying, get really good at simplifying, and then watch the videos for solving. So this is a very important skill that you have to master before you can solve. So I'll pause there and then record solving separately.